So I was on a video call with one of my friends who has been working in the analytics industry for some time now, quite a few years actually. And we were discussing a few things about data science in general. And he told me that he has never actually learned statistics. Yeah, he said he didn't ever even get a chance to learn statistics, and he also said that statistics did not help him, analyze the data, and he hasn't implemented any kind of statistics in the real world examples. You know how that made me feel. But keeping aside, so I thought that it's been quite some time since I have revised all the concepts of the basic statistics. It's quite a few years for me as well, actually. So I thought that the best way to learn would be to just create a video series of it, go to the concepts, and try to explain other people as well. So in my opinion, that is the best way possible to learn. That you learn a concept and try to explain it to others, and that's how you find your flaws. That's how you improve your learning. So this video series, Easy Statistics, is going to be about that. We'll be covering the basic concepts of statistics and a little bit of probability in general. So this is not going to be a longer series, I would say, maybe like 5 or 10 videos at the top. But we'll try to cover the fundamentals of statistics, and we'll try to cover them in the most easier way, trying to portray them in like a storyline, so that you guys and even me as well, so we get familiarized with all those things. So let's get this. So in this part, we're going to cover the basics of probability theory, random variables, and a little bit about PDF, CDF, and PMF. Now, you guys might be wondering, why do we need to go with probability theory? And you are right in some way, but to know the concepts of random variables and the distribution functions, we need to know some basic terminologies of the probability theory. So it won't take much time. I'll just portray some definition, try to explain them using examples, and we'll just move into some basic statistics then. So first of all, we have random experiment up here. Now, by statistical definition, a random experiment is an experiment in which the outcome cannot be predicted, or it is not known with certainty. Now, to explain you in easier terms, so a random experiment is kind of a task or an activity. So in machine learning or in data science, what we are doing is we actually trying to solve random experiments. That is all that we are doing. And when you are working with any kind of classification problem or any kind of binary classification problem, supervised learning problem, then you definitely have the labels, you definitely have the outcomes or the targets. But and when you give the predictions out of it, right? You give the predictions, but you have kind of a probability associated with it, or some kind of confidence number associated with it. So that is what a random experiment is basically is. So random experiment is kind of a task or an activity that we perform, that we conduct, and will definitely give the outcome, will definitely give the predictions, but we are not going to be completely sure about this. Okay, I guess this makes sense. Oh, to give you an example, let's go ahead with the simplest example possible of a coin toss. Now, if you are an average human being,
Wow!
so as I was saying, so if you are an average human being and you toss a coin once, then the probability of or the outcomes that you can see is either going to be a head or is going to be a tail. Now we know that there's a 50-50 chance of it, and that's why we are saying that while conducting an experiment or before even starting an experiment, we know the outcome, what the outcome could be out of the all the outcomes possible, but we are not completely certain about this. So that is what a random experiment is. And if we want to look into further examples, then we have a few examples here as well, like the outcome of a college application. So a person or a candidate, a student could be admitted to a college, he could not be admitted to a college, something like that. So these examples, the main reason we have put up these examples up here is we're trying to portray a storyline and the coming concepts of probability theory. So if you the terminologies that are coming ahead, we'll use these examples and try to see what they actually mean. So coming up next, we have the sample space. So sample space is nothing but all the outcomes that a random experiment could possess. That's it. So continuing our example, when you toss a coin, so we know the output could be either a head or a tail. So that is what the sample space of that particular experiment is. And again, so where does it actually fall? So we have our experiment up here, and within that we have a sample space S that contains all the outcomes. It's a universal set of all the outcomes possible for a specific random experiment. Now next up, let's see the examples of it. So the previous examples that we saw, the outcome of a college application, as I said, the sample space could be the student was admitted or he wasn't admitted. Similarly, for predicting the customer churn, the customer could churn, he could not churn, something like that. So this is how sample space and experiment are related. And we have just last term in probability theory, the basics of probability theory, that will all kind of create a story and give you the whole picture. So next up we have the event, and this is the I would say kind of one of the main things that we are interested in. So we created an experiment, right, of a coin toss or whatever it could be, and we have the sample space. We know what the outcome could be. We know what all the outcomes do we have, and now when we are actually conducting an experiment, we might have an objective, right? So this event is basically the outcome from all the sample space or all the outcomes that we have, right? And when we conduct that experiment, the result of that experiment or the outcome of an experiment is actually an event. Okay, so event is a subset of sample space, and the probability is usually calculated with respect to an event. That's completely true. That's a kind of a statistical example. But let's see how it fits into the complete picture. So event is basically the outcome, one of the outcome from all the sample space or all the outcomes that we have available for a specific experiment that we are conducting. So let's see how it falls into the complete bubble up here. So we have the experiment. Within that experiment, we have all the sample spaces or all the outcomes that could come, and then event is basically one of the outcome or a set of outcome from the universal set or the all the possible outcomes or the predictions that we have for a specific random experiment. I hope I'm clear. But let's see the examples. So the outcome of a college application, the sample space was that the student was admitted or he wasn't admitted, and the event or the specific information that we want could be the number of admissions with more than 80% in academics. So consider another example that we have. We are actually working on this machine learning problem, and we have the data set of all the students where we have their academic performances, their 10th grades, their 12th grades, and all those things, how did they perform in the specific subjects and all those things. And we are building a solution now. We are building kind of a a classification problem that a student would be admitted or not admitted, and the target label is definitely the sample space that we have available here, and the event. So using that data, we can find this specific event or this specific information out of it, the number of students with more than 80% in academics. So this is how the whole picture comes into it. I hope it was clear. So okay, now we move on to the basic concept of statistics now. So these terminologies were definitely needed to understand the basic concepts of statistics, because as I said, we are going to use it further in the definition of other statistical terms. So next up we have the random variable. Now the statistical definition says that it is a function that maps every outcome in the sample space to a real number.
अरे कहना क्या चाहते हो?
Now, this might actually sound that it's too much, but we'll try to again try to fit in the storyline that we have going on here. So we have an experiment. We are conducting an experiment. That experiment definitely would have some sample space or the outcomes, right? All the outcomes that an experiment could have, and within that sample space, we could have a specific outcome, right, or a set of specific outcomes that we are actually getting as an insight from the whole experiment. That is called an event or an outcome. Now that event or an outcome, it's not actually a real number. It's one of the possibilities, we can say, or one of the predictions that we get from whole of the sample space available, right? And now we need to somehow quantify it, because see, because we definitely need some kind of a probability value or a confidence value or a percentage value, something like that. So the event or the outcome that we are getting, it's basically one of the outcome from the complete sample space available, and we need to quantify it. That's why we need to map it to a real number possible. I hope it was clear. But if it isn't, this experiment or this example would just make everything clear. So let's say we are conducting an experiment where we are tossing a coin twice. Okay, so this is our experiment. Now the sample space would be that on both the tosses we get heads, right? Heads on the first toss, heads on the second toss. We can get head on the first one and tails on the second one. We can get vice versa, and the last one we can get tail on both the tosses. Now this is the sample space that we have defined, and all the outcomes are listed up in here. Now let's say we want to find the number of heads that we can expect, the probability of getting the number of heads, right? So the number of heads that we are getting in this example, each of the individual outcome in the complete sample space is actually an event or an outcome. Okay, and now we want to find the number of heads possible. So let's say we have a random variable x that represents the number of heads that we get from this specific experiment. Okay, and then now we need to map this to a real number. So x is the number of heads for the first outcome, that is h or heads. We'll get two heads. So you know, it's pretty clear. For one head and one tail combination, we're getting one head, so x would represent one. So we are mapping it to real numbers, and when we don't have any head, both the tosses get us a tail, then it's going to be zero. Okay, I think I guess it would make things clear. So this is a whole example. You may want to freeze the screen and try to figure this out on your own as well, but I think this should make the things clear. Now let's see, there are also two types of random variables. So let's move into that. So we have a discrete random variable and we have a continuous random variable. So discrete random variable, as it says, is made for so it's basically a random variable that can take only a discrete number of values. That's it. So it could be a coin toss example, it could be rolling a die, it could be the movie ratings up here, as you can see. So the movie ratings are ordered from 1 to 5, right? So we have like 5 ratings, 1, 2, 3, 4, 5, and any movie could be rated in one of these 5 values. So it's a discrete value, right? It's a discrete random variable. And discrete random variable, the distribution, or the description of a discrete random variable is given using a probability mass function, a PMF, which we'll look into it later, along with PDF and CDF and all those things. Next up, we have the continuous random variable, another type of random variable that we have available. So contrary to what we have for discrete ones, right? So a discrete random variable would only have discrete values, but for a continuous random variable, we have continuous values. So it could be, infinite values actually. It could be ranging anything from minus infinity to plus infinity, and it can take any real value. So by real value, I mean it could go like 1,000 places beyond the decimal point. So it's kind of a continuous distribution, and even you can look at the graph here, which says the heights of a US adult male, right? It is actually in inches, and the height could vary, from minuscule inches to a lot of difference between the individual heights and inches, right? That's why it's a continuous distribution. Another example could be market share of a company, right? 0 to 100%. So someone who definitely can have like the market share of 55.6%, but it won't be actually 55.6%. It could be 55.623091. It could go beyond decimal places to like a lot of decimal numbers. So this is what we have. And again, continuous random variable is described using a probability density function. But more on that in the slide.
Before we move on to the next slide, I just wanted to say that this video was taking longer than usual. I didn't expect it to get this longer. So I decided to stop this one right here. I don't want to bore you with all this jargon at once. We'll take things slowly, as I said. So the remaining parts of this slide will get covered in the next video. I'm going to split this video into two parts. And in the next one, we'll look deeply into PDF, CDF, and PMF and see their practical implementations as well. So make sure you subscribe to the channel, press that bell icon, and I'll see you guys in the next one. Bye bye.